afternoon, everyone. I want to introduce you to Johnathan Norman. He's just some random security guy from Project, whatever the hell that is.
Hello? All right. So yeah, my name's Johnathan Norman. I work at Logic, and for your obligatory cloud conference, right? Every conference has to have one, and this time I don't think I have it. So normally when presenters start a presentation and start talking, they often give you some background about who they are, their job title, CSO, or VP, director of X, Y, and Z. I'm not going to do that on this talk. Instead of going through all that, we'll just sort of focus on the data because that's more relevant than sort of my history and background. So a little bit over a year ago, I was doing a presentation to our executive team on the current threat landscape. And one of the primary sources of data for that report, or that presentation, was the Verizon Data Breach Report. This comes out every year. It's very, very popular in the industry. It sorts from a number of investigations that the Verizon Data Breach team does throughout the year. And recently, they've incorporated data from the Secret Service and added that to the set as well. And at the time, one of our executives raised an interesting point that yeah. All right. So one of our executives raised an interesting point that the typical customer at Verizon is much different than the customers at our company. And our company focuses on small to mid-sized businesses, hosted often at service providers like Rackspace and things of that nature. So does the attack profile differ? Our customers are mostly cloud clients. And the larger enterprise clients haven't really moved into those environments. And it was a really good point, but sort of selfishly, I was sort of frustrated because I was 2 slides into my presentation in front of a bunch of executives. That's why I had an hour worth of talking to do, and he sort of already dispelled my data. So I was less than thrilled with Dave at that point. Oh, this is really dark on here. Anyway, so it kind of raises this interesting question for me. So, you know, does cloud security differ than security in a colo environment, or if it's done in-house, right? And so I boiled this down to 2 key questions. First, are public cloud environments inherently less or more secure than other environments? And if so, what are the differences between those 2 types of environments? And I felt that or presumed that getting this data would be rather simple, right? I mean, we hear a lot about the cloud. There's commercials everywhere now. It's in everyone's marketing literature. It's all over the place. So like most guys, I set out to sort of use somebody else's information instead of doing my own research. And one of the first organizations I came across was the Cloud Security Alliance. The Cloud Security Alliance is sort of formed by Google, Trend Micro, a lot of big names that I think you've all known and heard of. And their focus is by and large setting a series of standards, policies, procedures for auditing cloud environments, looking at threat profiles in cloud environments, and so on. So they have some sort of key initiatives. These are sort of a small list. One of the more interesting ones that I thought that, was rather funny is they want to do a cloud certified sort of stamp for providers of cloud environments saying that this is hacker safe or something of that nature. Doing audit standards for cloud environments, and things of that nature and so on. And if you look at the membership of the CSA, it's by and large corporate. Roughly 80% of the members of the CSA are formed by corporations that sell cloud products, which was rather interesting to me. The individual memberships, if you look at the individuals who actually head the working groups within the Cloud Security Alliance, it's rather interesting. For every working group, the individuals that lead it sell products that cater to that group. And you can sort of view this in 2 ways. You can say, well, it's good, right? They have individuals who are in that industry, and they should know about it. Or you could say that there may be a conflict of interest there. And almost all these individuals are CSOs, VPs, someone at an executive position. But I thought I was in luck. So they did publish their top threats to cloud computing, which should, in theory, be my answer, right? what are the key things that are focus and threats to the cloud environments. And here's their list. And I'm not going to go through all of these because some are rather boring. Abuse and nefarious use is one of the interesting ones. The #1 threat to cloud environments, according to this list, is someone using it for bad reasons. So using stolen credit card information to DOS somebody or just do bad things. Which to me is no different than any other environment, but you know, whatever. Insecure APIs made sense, right? These APIs are often REST-based. They suffer from a lot of the same issues that you see in web applications. So logically, you know, that seemed like a viable risk, but it was still sort of, I guess you would say, you know, kind of weak in nature. #4, shared technology issues, focuses on the fact that these environments are inherently multi-tenant. Often you have hundreds of customers sharing storage, and the only way that that is separated is through some sort of API or software means. And there was a bit of a risk there that that data could be compromised. And my favorite is #7. The 7th risk to the cloud is everything else that we don't know. It's the unknown. That's the risk. And it kind of brought me back to the first point of, I don't know what the hell I'm going to do with this information. And I don't think other users would find this information terribly useful either. So, needless to say, I threw this away. It was a complete waste of time. It was a dead end. So I took a different approach. What if we looked at what security practitioners are doing in cloud environments? So I found a survey. This was sponsored by CA. It was done last year. And it's a survey of practitioners who are focused and invested on taking care of cloud environments. And this is in the first sort of 3 pages of the survey, and I thought this was rather interesting. And I'll read this because it looks like it's kind of hard to read. But IT practitioners, you know, the respondents, lack confidence in their organization's ability to secure data and applications deployed in cloud computing environments, especially public clouds. So already off to the start, your respondents are admitting they are not confident in their ability to secure cloud environments. They then follow that with the majority of those practitioners in the US and Europe admit that they don't have a complete knowledge of understanding of what is and isn't in a cloud in their environments. And then my favorite, 67% of the respondents felt that their cloud was not properly managed. So we have a very, very clear sort of admission by the people responding to this survey that they have no clue of how to secure the cloud. So what did CA do? Well, they asked for their recommendation on how to secure the cloud. And here's what they recommend. Network intelligence systems, encryption for data at rest, identity federation, whatever the hell that is, log management, and virtual private networks. So of all the individuals who don't know how to secure the cloud, this is what they recommend. So once again, from my research, it's not terribly useful information. I mean, you have users that admit that they don't understand cloud security, giving you their opinion on how you should secure the cloud. So, another dead end. So, instead of looking at practitioners, I went ahead and said, let's take a look at what the executive opinion is. So, just general perception, right? How do people feel about cloud security and what are they thinking? 40% of the respondents to this survey, sponsored by Trent, feel that security requirements are not met by current cloud offerings. Their policies, procedures don't allow and don't support some of the needs and requirements they have for their environment. 50% of respondents, and this is kind of a staggering number, say the key reason why they haven't moved to the cloud is because of security, which is pretty interesting. But 85% of those encrypt at least some of their data in the cloud. So if they are in the cloud, 85% are using some form of encryption for whatever reason. And the overwhelming majority say that shared storage is vulnerable if you don't have some form of encryption in place. So this is just sort of what the executives feel, how they're thinking about the issue, and so on. So needless to say, I found myself at a dead end without any useful information. So I decided to take a look at it from a historical context. If you look at all of these papers and all the publications, they often reference various key events in sort of cloud security history, as it were. First being the red pill concept, the idea of detecting within a single CPU instruction that you're in a virtualized environment. Following that, the blue pill concept was using a rootkit within the hypervisor that's undetectable. And she kind of put this all together at Black Hat in Vegas and did a rather interesting presentation. Following that, Immunity Cloudburst exploited a device driver within VMware to gain access to the hypervisor in that situation. So in all of these are sort of hypervisor focused until SensePost, a South African company who's done some very, very interesting research. If you guys aren't familiar with them, I would definitely suggest checking them out. Called Clobbering the Cloud. Basically, through abusing vendor APIs, they were able to do a number of interesting things in Amazon, Salesforce, etc. My favorite was turning Salesforce.com into a NICDO scanner. They called it SIFDO. They're able to bypass the computing restrictions within the API and make it a web vulnerability scanner, which was rather interesting. And then shortly thereafter, they did their cache on delivery talk, where they were able to steal a memory from other machines or other hosts in other areas that they weren't supposed to have access to by taking advantage of issues within Memcached. So, needless to say, I really couldn't do much with this. And I thought about it and I realized that I actually had all the data that I needed to make the decision. It was just a matter of parsing it out and making use of it. So I work for a company called AlertLogic. And I'm going to try to avoid the sales pitch. But basically what we do is managed IDS, log management, vulnerability scanning, etc. And we sell largely through service providers. Service provider being companies like Rackspace, Terramark, Savvis, Amazon, etc. So we partner directly with these guys, they sell our products, and we have rather close relationships with them. And all of these environments have some form of public cloud. So what if we take our data, separate it out, because we have standard enterprise customers as well, and look at the attack differences in both over the course of 1 year. Do the attacks differ? Are some more successful than others? Do we see different trends and patterns and changes, etc.? We hold roughly 60% of the market in the US, and that's been growing rather rapidly. So, some notes about the data that we have. Every attack is validated by a human. So, every attack goes through a correlation engine. That engine then feeds data to a root and security analyst, and those analysts will then escalate the incidents to our customers. So for everything that we call an incident, which is a validated attack, we have human verification. So the false positive rate in this is nearly zero, which is a pretty nice data set. The problem, however, is that we're network-based IDS. We don't see what happens on the host. Sometimes we do, but it's rare. So how do we get access to that information? What are the attackers doing on those machines? And what are the steps that they're taking? So we set up some honeypots. Since we do have very, very close relationships with these providers, we don't have to necessarily follow their AUP. So whereas other guys can only do certain things with honeypots because they can't connect out to certain command and control servers, etc., we can do that with, to some degree, as long as we don't get the service provider in some sort of trouble, which is rather nice. We set them up in multiple environments around the world, UK, Asia, all over the US, etc. And then we advertise that these machines are cloud-based, so setting aside the fact that these IP addresses are clearly in Amazon or something like that, the host names were mybps.whatever.com. The message of the day would say Cloud Dev Box. We also populated the databases with fake credit card information, fake names, things of that nature. So they look very, very real. These are high interaction honeypots. They're able to execute shell code. So it gave us a pretty nice data set. And then there's a bit more to this. We have access to service provider investigations. If a cloud host, in some cases, depending on our agreement with the service provider, is used for nefarious purposes, we can get that box, do analysis on it, see what happened through agreements with the customers and so on. So we get some forensic data. We work directly with the service teams on their investigations, so we have that information as well. And then the non-cloud clients give us the same data to work with in the same manner. So some notes about the data. Our focus for this presentation is largely public cloud environments. We have roughly 120,000 attacks over the course of 1 year. As I mentioned, 1 year. And we remove policy violation incidents from the data set. What I mean by policy violation, it's Bob going to a porn site, chatting, things like that. Not necessarily what I would consider an attack. So the combination of all these different data sets, the validated attacks on the wire, the honeypot data, the forensic investigation data, we're able to sponge that all in and sort of get a good idea of what the reality is of, quote, security in the cloud is like. So, to our first question, who is more secure? Sort of going back to the survey data that we had, right? 40% say that the requirements are not met by current cloud offerings, and half of the respondents said the reason they weren't using to the cloud or moving to the cloud is because of security. In our data, and when I refer to data loss, this means a reverse shell, personal data being transferred off the network, anything where sensitive information is being pulled from a host and provided to someone off-site. 12% of the non-cloud clients were impacted in some way by this, whereas only 1%, and it's actually just shy of less than 1%, of the cloud clients had some form of data loss. Now, there's some important things to keep in mind with this. The non-cloud clients tend to have a lot of desktops, right? There's not a lot of desktops in the cloud, so that contributed a lot to this. But there's no indication, at least from this data, that cloud environments are in some way less secure. In fact, it kind of contradicts the opinion that people can do it better internally. Non-cloud clients were 6 times more likely to have misconfigured hosts. And when we say misconfiguration, they're allowing net BIOS from external sites. They're leaking personal information they shouldn't be leaking. Just poor config options, all around the board. Default passwords, things of that nature. So not only are these environments more secure, or at least it seems from the data, they're also better managed. So we have noticed some differences, but how does the attack profile differ? And this is rather interesting. Thank you. Cheers, folks. So for whatever reason, and we don't have an explanation for this or understand why, but it's an interesting point, cloud clients had twice as many brute force attempts targeting their servers as non-cloud clients. This is RDP brute force, SSH brute force, form-based brute force attacks. We don't know why. We looked to see if those were coming from other cloud customers. They weren't. But attackers were by far more often attacking cloud clients who were trying to find weak credentials. Trojan activity is significantly less in the cloud environments as well, whereas it's far more popular in enterprise environments. Our assumption and our belief is because that's kind of because of the desktop environments, right? You don't have desktop users in the cloud. And then the attack preference is kind of interesting. So in the honeypots, if you have NetBIOS available, if you have SQL available, and you have the web application available, which will the attackers hit first? By and large, and this is in both environments, non-cloud and cloud environments, they always target NetBIOS first, for whatever reason. Second to that was MS SQL or MySQL, depending on what flavor of the OS we had. And then third was HTTP. And then my favorite, shared technology issues. So one of the primary concerns of a lot of users is shared technology issues. So multi-tenant environment, shared information, people getting access to data they otherwise shouldn't get access to. A lot of this stems from the virtual machine escape research that we see in the media today and in security conferences. Do we have any data to support or contradict that? So back to the data, 85% are using some form of encryption, 55% say shared storage is vulnerable without it. But over a year time span, we never saw even a single attempt to use a virtual machine escape exploit. No one ever tried. This includes did forensic investigations from the compromised host. This includes the honeypots, etc. So not only are they, setting aside the fact they're not successful, they're not even trying. Yet, 85% of these users are encrypting their data. And then, the attack preference is to gain control of the host first. The common knowledge or common sort of set of wisdom is protect your data, right? That's the most interesting thing. And yeah, your data is valuable, but I mentioned we had fake credit card data on these hosts. The attackers, 8 out of 10 times, focused on root access of the device first and went for the data second, which was rather surprising to us. So how do we get here? There's clearly sort of a perception and reality gap. And here's sort of my hypothesis, or here's what I think. It starts with industry experts. All too often, we go to a CEO, CSO, VP, and ask their opinion about security. You see this all the time in sort of New York Times. You see it in the Cloud Security Alliance sort of threat working groups. And I'm not saying these individuals are necessarily bad at security. They may be great. But your typical CEO is a great businessman, right? I mean, you hire a CEO to run your business. You don't hire a CEO to sort of secure your network. At least most people don't. I never have, and I never will. But we do that, right? We go to these individuals and we ask those opinions. So are we properly qualifying what a, quote, industry expert is when we get these guys' opinions? And then my favorite, bloggers. X, Y, and Z blogger said, anonymous is raging cyber war and yada, yada, yada. But if you think about it, what makes a good blogger? It's the same thing that makes good news, right? Sensationalism, things that attract people's interest, but not necessarily factual data or valid opinion or good credentials. It's just interesting, sensational items. And the best analogy I can think about this, or sort of apply this to, I would imagine that most individuals in this room, if you had an illness and you went to a hospital, you would not go directly to the CEO or CFO and ask for how to remedy your issue, right? You go to the doctor who's done the most number of surgeries, who's seen your case the most number of times, and you ask their opinion. But in our industry, we go to executives. We do the exact opposite of that, which is sort of odd to me. So first issue I see is we're not properly qualifying what a, quote, industry expert is. Well, let's say you do qualify them right? Even experts get it wrong. Doctors are known to misdiagnose cases 4 times out of 10. Moody's maintained a AAA rating of AIG until the day of their collapse. And another favorite of mine, for those of you who are not familiar with the Citigroup hack, or the recent Citigroup hack, the attackers were able to enumerate credit card numbers by guessing them. So the credit card number was visible in the URL. If you changed it and it works, it's valid. If it didn't work, it didn't work. It was invalid. So they wrote a script. They're able to enumerate a few 100,000 credit card addresses, and that's how they, quote, hacked Citigroup. The New York Times expert, who, New York Times is a pretty reputable paper, said that this type of attack is hard to prepare for. And I think anyone who's ever written a web application knows that it's actually rather easy to prepare for, and kind of an obvious thing. So even when we have experts, they get it wrong sometimes. They're not perfect. And so we're in this interesting sort of feedback loop, right? We have marketing agencies that, like Tier 1 Research, 451 Group, and they do market research. And really what market research is getting the opinions of industry experts, aligning them, and then selling those opinions back to the same experts in a weird way. They'll query CSOs, or they'll query CEOs, get their opinion on a particular matter like data encryption, publish that research, and then sell. And so it's sort of this endless loop. Some of it comes from the security research community, but it's very, very rare that it applies. So this would never fly in academia, but in our industry, we call that research. So this sort of brings me to my conclusion. So I didn't pick the cloud topic today because I care if you guys move to the cloud or not. Frankly, I'm completely indifferent. Whatever, do what you want. Why I picked it is because the cloud topic has become so overly hyped by marketing departments, CEOs and executives, that it provides a good example of the way we do a bad job of making decisions in our industry. We talk about spending millions of dollars on all this new equipment, yet you still get hacked. Well, why is that? All the research says this is what you need to do. And instead of saying, well, maybe the research is wrong, we say, oh, they built a bad product, or they didn't do this right, or they weren't compliant. But maybe, just maybe, the compliance standards are wrong, because the process we put in place to make the decisions is faulty by nature. I'll give you an example. So you remember the trend micro data I mentioned earlier, the CA data? Well, on Trend Micro, at the same time they published their survey, their market research, it also coincided with the release of an endpoint security encryption product that they're now selling for the cloud. In CA's case, the survey where they asked the individuals, how do you feel about the cloud? And they all admitted they had no idea, and they offered 7 key technologies. Every one of those technologies is sold today by CA. Oh yeah, and a bonus, both CA and Trend Micro are part of the Cloud Security Alliance, offering recommendations on what you should do to secure your cloud. So the process, in my opinion, is fundamentally broken. So how do you solve it? And it starts with asking questions. First, you qualify an industry expert. That's why I didn't tell you guys my job title at the beginning of the thing, because it's not important. The fact that I may be the founder of Alert Logic or a director of research or what have you isn't relevant. What really matters is the validity of my data. The process in which I went by getting that data. Was it faulty? Was some degree of bias, etc. And so that's the first step. In knowing that job title does not make somebody an expert in a given field. And then you need to question the methodology. If CA is sponsoring research on a new product that they're launching, maybe their methodology is flawed. Maybe inadvertent is biased toward things that favor their opinion. These things happen. It happens in medical research all the time. But the difference is in medicine, researchers question other researchers' work. Today, we just roll our eyes, right? We see the new PCI compliance standards, at least I do. Your eyes glaze over and you're like, these guys are idiots. Right? And if we continue to do that, if security researchers continue to do that, we'll just sort of perpetuate these same silly requirements, the same silly policies that don't really help people. And then they get, they'll continue wasting money and getting angry and, same result. And then look for bias. I referenced at the beginning of the presentation that, I looked at in the CSA who does what, how is it funded, and how is it works. But how often do you do that when you hear that an expert says you should do the following? In my experience, not a lot of people, even great CEOs, and I've worked with some very, very talented executives, tend not to question those assumptions. And I think we should. And it's not until we start doing this that we'll truly solve the issue of securing our customers and developing proper standards to move us forward. And that's all I have. And that's me.